The supremum, infimum, maximum, minimum, interior, and the boundary points for the following set. R is a rational number. R is between 0 and square root of 2. So the first thing we're going to find is the supremum, which is our least upper bound. The set contains only rational numbers less than square root of 2. Square root of 2 is an irrational number that is not in the set. However, there are rational numbers arbitrarily close to square root of 2 from below. So the least upper bound of the set is square root of 2. So we'll say that supremum s is square root of 2. Now for the infimum, which is the greatest lower bound, we see that r is bounded below by 0, and that is the greatest lower bound. So we'll say the infimum is 0. For the maximum, it must be an element of the set that is greater than or equal to all other elements. Here, square root of 2 is the maximum, but it's not part of the set. So it turns out that there is no maximum element that exists because we can always find another rational number that is close to square root of 2. So we say that the maximum does not exist. Now, for the minimum, clearly 0 is, we said it's the greatest lower bound, and it happens to be in the set, so the minimum has to be 0 as well. Now for the interior points, these are points that which there exists a neighborhood entirely contained in the set. So if we're going to take a neighborhood of points in our set S, we will not just have elements in set S. We're going to have irrational numbers as well. So no matter how we create the interval, there's always going to be irrational numbers in there. So we'll say that the interior of S is empty. For boundary points, these are points where every neighborhood contains points both in the set and outside the set. So in the set, the boundary of the set includes all points from 0 up to square root of 2. This is because any two real numbers, you can find both rational and irrational numbers. So we'll say that the boundary of S is 0 and square root of 2 inclusive.